Okay, great. Fantastic. All right. Well, maybe we should get started in the interest of time and getting things going. I see we've got a few folks in here yet, and or already, and hopefully we'll get some more to show up. But thank you all for taking time today on this Thursday to join us for this Lunch and Learn with Brian Brettschneider and Rick Thoman, who, in my mind, are sort of like the Lennon and McCartney of weather and climate in Alaska. Just two brilliant men that help us understand these things and really help break it down. Many of you have probably heard Brian on Ask a Climatologist, and Rick has joined us for Talk of Alaska and a whole lot of stories, as you're all aware of through the years. And so we'll get started here in a little bit. Again, just to catch people up on the information, Rosie is going to unmute everyone. So then you'll be able to mute yourselves and then unmute when you want to ask a question. But please, especially if you're in a kind of a noisy area, mute yourself so we can hear Rick and Brian. Now I'll give you a little bio information about these two gentlemen that you already know, but maybe you don't know everything about them. Rick Thoman has worked as a weather and climate professional for 40 years in private, public, and academic sectors. He produces reliable Alaska climate information, which is so true, and graphics describing Alaska's changing environment. His work spans the bridge between climate science, Alaska communities, and media, which is really important. And the big reason that we're here today is our role in this, helping people understand what they're facing. Brian Brettschneider is a climate scientist that works for National Weather Service's Alaska Region Headquarters. He has a background in geography, ecology, and climatology. Prior to joining the National Weather Service, he was the research scientist for the University of Alaska Fairbanks and worked on projects related to Arctic sea ice and fire ecology. Prior to UAF, he worked for 15 years in the private sector for an environmental planning firm, occasionally dealing with landscape planning. Brian is one of the leading experts on current Alaska climatology and climate processes. He works closely with people in both the research community and on the policy side. Within the National Weather Service, he is one of 6 climate services program managers nationwide and works to develop climate products, training, and materials for use in Alaska and the lower 48. And on Twitter, you may know him through his Climatologist49 account. Okay, so I think we'll get started here. Rick and Brian have some information they're going to share, some slides that are meant to just sort of spark questions and conversation. So Rick is going to start that now, and we'll, as people have questions, you can unmute yourself or put a question in the Q&A section of the screen. I'll be watching that, and we'll let them take it away, and let's learn something.
Okay, thanks, Laura. Can you hear me okay?
Yes.
All right. So, hi, everyone. Thanks for taking time out of your Thursday to join us here. And so Brian and I put together just a few slides here, really to kind of be conversation starters. This is more information that might help you be a better, do a more informed reporting on weather and climate issues for, in particular, for Alaska here. So this is not really a what's happening or so much how things are changing. There's a little bit of that, but really, hopefully, to help you think about and help understand some of the weeds that we deal with that are important for at least for background for the work that you do. So I'm going to start us off here, and then I'll pass it to Brian, and then we'll just move into the conversation portion of the program. So as Lori mentioned, I'm here in Fairbanks, work at the Alaska Center for Climate Assessment and Policy, which is one of the groups within the International Arctic Research Center here on the UAF Troth-Yithak campus, the traditional and never ceded lands of the Tanana Dene people. So I'm very happy to be with you today. Let's see if we can make, all right. So one slide just to start off. Lots of confusion sometimes with the the difference versus weather and climate. In the most strict sense, weather is really just the instantaneous state of the atmosphere right now. What is the precipitation rate right now? What is the intensity of this solar energy right now at this particular place? That's not really quite how we use it. We get a weather forecast for a few days that is attempting to describe some kind of average condition. And that really moves into climate, which in the end is nothing but the statistics of weather. So you think of the weather forecast on your phone as a high temperature today. That, of course, is a statistic. You could take a temperature reading every second, and what that forecast is supposed to be is the highest value in that all those seconds of observations in a given day, say, or things like how much rain or snow there is today. That's a statistic. It's going to be the sum of the rate of precipitation through the day. Again, not usually how we use that, but it's important to understand that distinction when asking about weather versus climate. Usually we think about climate over longer periods of time and the statistics over those time frames. So we don't really think of today's high temperature as a climate statistic. We think of it as weather, but it really is, but that's not normally how we use it. So here's the little quotes to, that might be helpful. So climate's what you expect, weather's what you get, attributed to Mark Twain. I don't think there's any evidence that he actually said that, but sounds like something Mark Twain would say. Or weather's what's in your closet, climate's what's in your closet, and weather is what you wear today. So it doesn't matter that the average temperature in Anchorage in January is, say, 20 degrees. If it's 5 below zero and windy, you're probably going to wear something different than if it was average. And if you're a sports fan, you might like the little baseball analogy here. So, Babe Ruth is a great home run hitter. That's the climate scale. That's the long view, the statistics of Babe Ruth's career. But that doesn't mean that Babe Ruth hit a home run every time he came up to bat. And in fact, Babe had some unproductive games as well. That's the instantaneous, the weather portion of Babe's career. So weather versus climate in a lot of what Brian and I do. That's a really important distinction. All right. So most of my stuff here really is how to help you contextualize weather and climate information. So right now, 2023, we live in the golden age of weather observations in Alaska. There are hundreds of automated stations reporting the current instantaneous state of the atmosphere around the state. That is just so dramatically expanded from when I started in this business in the 1980s in Fairbanks. On a midnight shift at the forecast office in Fairbanks, you would have at 3 o'clock in the morning, you'd have a weather observation from Fairbanks, from Galena, and from Nome, and that is it, going west of some broadly west of Fairbanks. Now there's dozens of observations at 3 o'clock in the morning in that time. So that current instantaneous state of the atmosphere, we're living in the best of times. Looking at the ocean, we are certainly better in the Gulf of Alaska and along the Aleutians than we were in the 1980s, but northern and western Alaska are lagging. If you didn't know this before, you probably learned it during Murbach. There are very few coastal ocean level observations along the Bering Sea and Chukchi Sea coast. It is slowly getting better, but it is getting much worse in the realm of climate observations. So those summary statistics of weather over time, there's been a massive loss of place-specific climate observations over the last 40 years. And things like temperatures have been hard hit, but snow and precipitation have been especially hard hit as far as having that even daily, still a statistic, daily level climate observations for precipitation snow. And I'll show you just how dramatic those changes have been here. So here's where we're at. Just to illustrate, now you don't need to see any of this. So just look at the number of points. So this is just from earlier this week there on the left-hand side. This is for a particular hour. This was the real-time weather observations were available. If you look hard, you can see there's definitely more Kenai Peninsula, then up the Parks Highway to Fairbanks, and then down the Alaska Highway along the Richardson Highway. So there is a preponderance of weather stations near the road system, but there's reasonable coverage. In most areas, there's still some gaps. Brooks Range, Western North Slope, Southeast Alaska has a lot as well. Even down the Alaska Peninsula, Southwest Alaska, a lot different than the old days. On the other hand, when we look at just monthly precipitation, which is just the sum of the daily precipitation, and you can see here from one of the primary climate data sites that we use every day. This is the March precipitation. There's a bunch of junk data in here, which I have X'd out, and you can see that especially off of the road system, there is much less precipitation data in this example in March than there would be real-time weather observations. And the distribution of where we have information is wildly different along the road system, and especially in Southeast. It's pretty good by Alaska standards. It's not, nowhere is it good compared to most of the lower 48, but clearly Western and Northern Alaska, there's a real lack of that kind of information. Now, here's an example of the loss of snow information. March 1981, total snowfall is on the left. This March is on the right. And you don't have to count every single one just to see that there's been a dramatic loss. And look at the utterly complete loss of snowfall observations across Western and Northwest Alaska. There weren't a lot in 1981, but there were some. And that is utterly gone now. It's really a sad state. And of course, everywhere in Alaska, snow is an important seasonal component of the climate. We live with it, we play with it, we drive with it, we work on it. And so lacking this information is really a major loss and a big change from what we had. Now, that's the bad news. The good news is that just in the last few years, there's come online basically computer models of climate that allow us to get a much more thorough view at the larger than point size scale. So this is not a replacement for point specific observations, but it does allow us to get a much better handle on, say, Alaska as a whole climate. This is an example of the analysis of precipitation. In this case, this is the percent of normal precipitation that fell in March. And you can see it's a computer model. It's a moderately fine resolution, about boxes at about, trying to do the math in my head, roughly 15 miles by 15 mile boxes here. This is the only source of information we have for large portions of Northern and Western Alaska. But even though the resolution this is the finest scale that we have for an operational climate analysis model, it is not good enough for areas with very complex terrain. That is to say, virtually all of Southeast Alaska, even the Anchorage area with the mountains both to the west and east of downtown Anchorage, this is still not good enough. And so this is not a replacement, but it allows us to say something meaningful at least at the regional to sub-regional scale. But we cannot turn off the Anchorage Airport data and think we can just use this. It doesn't work that way. That time may come where this gets better at the very, very small scale, but we're not there yet. And that's what I have, and it's up to Brian.
All right, thank you, Rick. And I think just for housekeeping purposes, if you have questions for Rick, you probably hold off until after I finish my little segment here, which won't be that long, and then we would, I guess, open it up for discussion. So I want to follow on a little bit with what Rick did, and then go a little bit different direction. And first is again to highlight how, as Rick noted, we have more temperature observations than ever before, but our snow and precipitation observations are dwindling dramatically. And the map that Rick showed included and was mostly cooperative or citizen observers snow data. If we look at a little higher level, if we look at what we used to call first order or government, basically government collected data. If you look on this map, you see three kind of light red dots. Those are the three locations where we collect snowfall and snow depth data as part of the official climate record by government employees or government contractors every day at midnight. So Juneau, Anchorage, and Fairbanks. And all the yellow dots are lower 48 stations. So they're not other Alaska. They're all lower 48 stations that collect the equivalent data. And as you can see, it's literally, an order of magnitude or 2 orders of magnitude difference. In the area that is covered by an equivalent area of Alaska, there is 22 times as many snow and snow depth recording stations. So we have other, cooperative, SNOTEL, and some other places that we use to fill in the gaps, but it's not good for measuring the most important climate variable we have, arguably in Alaska, and that's snowfall. So next, Rick. So, Rick talked about kind of, I think climate, and everyone really should in different time scales. We should think about it looking backwards, so an average of what's happened. But we also want to be able to think about it looking forward. And so climate scientists, many of them look at how, the evolution of the climate system. What's it going to be like in 5 or 10 or 100 years? So it is important to think about it in terms of both looking backwards and looking forwards. So in the looking backwards, we have lots of, because we have a fairly robust climate record now, and again, in terms of snowfall and precipitation, the quality and density is actually getting worse, not better. But we have a long enough period of record where we can start to do some meaningful analysis of where we were versus where we are now. So, so basically some trends, some simple trends and some complicated trends. And here's an example of a trend series that the National Center for Environmental Information, formerly the National Climate Data Center. So this is the US federal government climate agency. It's within NOAA. They put together some tools, and here's an example of the April 2023 temperature anomalies. And of course, it was a cool month statewide. I think it was the 5th coldest April, if I remember correctly. And you can also do trends and rankings and so on. So next. Now, I threw this here because, as most of the people on the call probably know, we are very likely heading toward an El Nino. And the question I get most of all is, well, what's going to happen? What does El Ninos mean in Alaska or in other places? And this is fundamentally a climate question. We're not really asking, well, what did the computer models say is going to happen? We're saying, what has the climate done in these same situations? And we have this kind of underlying assumption that, well, what's happened in the past should be a guide for what will happen in the future. And in many cases, that's a valid approach to take. It doesn't always work out that way. All things being equal, we should have expected April to be warmer than April's past, because that's the trend, and that's our new climate. Didn't work out this year. It was a cold April for a variety of reasons. But in this case, we're using climate to ask the question, what are El Niños like, in Alaska, in Hawaii, in the lower 48, based on the climate record. So this is a really kind of an important way that we use climate to answer some fundamental questions. Next slide. And then we also use it to do kind of trend analysis and to put the current climate in context. So we would say here in Alaska, and I think most people would say, well, I remember it used to be colder, right? If you've been here long enough. Well, that's kind of a qualitative assessment. And so how do we quantify, well, it used to be colder. Well, we could say, well, in Anchorage, the average annual temperature used to be 34. Now it's about 38. Okay, that's one way. We might say, well, there used to be snow on Halloween most years, and now it's only half the years, for example. That's another way of doing it. This is an example that I put together that looked at, well, if you looked in the past using the climate record, what were the 15 coldest days of the year? Now, how often do those occur? In this case, it's about under 7 days a year. So for most of Alaska, so that's about half. So half of the coldest days of the year, or what were the coldest days of the year? Now we only see half of those. So again, another way to use climate to put things in context. Next slide. And then, a question that I'm asked frequently, I'm sure Rick's asked frequently, and that is this the new normal? Or is this what our future looks like? And those are tough questions to answer. And we use a combination of the historical climate to put it in context, and also climate projections to say this is what we think will happen in the future. And a really good example of this was ex-typhoon Merbok that came up through Alaska to the Bering Sea last September. And so from a climate point of view, it really formed in an area where storms generally don't form. And then it took a path that storms generally don't take. And then it had impacts that were quite exceptional. And so there's multiple kind of Venn diagram circles of climate and weather, and then trying to figure out where all those circles overlap, is a really important climate question for how we as a state prepare for the future and potential adaptation and mitigation strategies we might think of. So that's my presentation. Those are just some high level thoughts of ways that I think about climate, and that's what I've got. So Lori, whatever you want to do next, I'm passing it off to you.
All right. Well, thank you both, Rick and Brian, for this excellent information. And hopefully people have questions. I know I have a couple, and folks should just unmute themselves and jump in or put questions. I see there's something in the Q&A. I'll check that out too. But one question I had was when you were talking about the loss of place-specific climate observation stations over the past 40 years, why is that happening at a time when we should be adding more and knowing more to help us better understand these things? Why has there been such a loss? Is it strictly funding, or what's happening?
That is an excellent question. And the answer is ultimately the automation of observations. Things that are easy to automate, like temperatures, like winds, like pressure. As I said, we have way more of that, but things that are harder to automate, like precipitation, there is no good way to automate snowfall. Snow depth can be automated to some extent in areas that don't get a lot of wind. So scrap all tundra Alaska gets a lot of wind. So automating snow in that environment is you don't get reliable information. So it's really the automation, and then not quite at the same time, there was a lag, but now the almost complete removal of any human input into that. So automated observations came in, and at many places, those were supplemented or augmented with people basically being the truth and adjusting as needed. And those people have all been or almost entirely been removed. And that's, of course, that's not an automation issue. That's a policy issue by the agencies that do that, which is primarily the Weather Service and the FAA in Alaska, with a smattering of Department of Defense. So that's really the crux of why we're losing this information. This is not unique to Alaska or the United States. Very similar problems in Canada for exactly the same reasons. On the other hand, in most of Europe and Asia, automation has not proceeded, especially for climate observations, the way it has here. So the observation nowadays is quite similar to the past.
And then following up there, before we get to some other questions, there's only 3 stations in the state reporting snow depth. That just seems crazy. Is that an expense issue as well, or why do we only have 3?
You want to take that, Brian? That was your map.
Yeah. So those are the 3 ones that are what we call midnight to midnight. So they represent a calendar day, and where a government employee or a contractor is actually taking the measurement, a human being. So we do have cooperative observers, citizen observers, and there's probably at least 30, I'm just guessing, at least 30 or so good locations around the state where citizen observers are taking snow measurements. And as Rick said, there's really, especially for snow and especially in windy areas, there is just no substitute for a human being sticking a ruler in the ground. That is just hard to automate. The Weather Service made a decision to, at locations around the state like Yakutat and Cold Bay and McGrath and Nome and Kotzebue and others, where we used to launch weather balloons twice a day. We had a staff of several people at those who launched the weather balloons, but they also importantly took the climate observations. Those are now automated weather balloon launchers. So there's not a need for people to launch the balloons, and as a policy decision, it was decided to have fewer staff at those places, usually I think just 1 staff member, and they can't be up at midnight every day taking an observation and doing their other stuff during the day. So there just now isn't any people to take those.
All right, well, I don't want to take a bunch of time. I've got tons of questions, but let's get to some others here. Tom Hewitt has his hand up. Hi, Tom.
Hi. Thanks for doing this, Brian and Rick. Appreciate you taking the time. Just had a question. I mean, obviously one way that a journalist who is doing a story on either a weather or climate related phenomenon has to kind of get the lowdown on, say, how a particular day stacks up in terms of a snowfall total historically, is to call up somebody like yourself and say, hey, where does this stack up? But are there tools where we can, maybe save you guys having to respond to that phone call that you would recommend in terms of, just those questions that we might have, on, is this a story? Is this not a story? Is this a big deal or not?
if I could take the first crack at it, because I'm going to pass it on to Rick, because there is a great website and a great tool that will answer a lot of those questions. As a condition of my employment, I am not allowed to give out even the name of it, I don't believe. But Rick doesn't face that same restriction.
I do not, and I will be happy to give you the keys to the climate kingdom. Like any quasi-technical information, the more you know about it, the smarter you'll be. But if you go to your favorite search engine and search on, well, let's go with SC ACES. SC like South Carolina or state climatologist, and ACIS. And all that is just basically a front end web interface into the National Centers for Environmental Information's database. So it's the quote official database, but it's a very powerful way to interrogate that. So today there's 3 inches of snow in Anchorage. Is this a record? Is it close to a record? Going through SC ACES, you could easily find that out.
Well, that seems really helpful. Go ahead, Brian. Did you?
I was just going to add, it is not user-friendly, but it is incredibly powerful.
Yeah.
And once you get the hang of it, it will answer practically every question you have, but there's a learning curve.
There is a learning curve for sure. But I should say there's a learning curve even for relatively simple searches, but it doesn't take too long, but it does take a little bit of time to learn how to do simple searches. But this and another version of this called XM Climate is what Brian and I mean, we live in this space. I just put the web address for SC ACES there.
Oh, thank you. Yeah,
so,
thanks for that.
Yeah, it's a very powerful tool. There are other ways to do this. That certainly is one of the big changes that I've seen in my 40 years in this business is the almost complete availability of information that even until the internet age and really maybe until the early 2000s, you had to go to a weather office to get, and now it's virtually all publicly available. There is very little information that is kept from out of the public domain in this country.
It seems like maybe I'm sure folks will check this out. I will after this session, and maybe we need a future session on how people can best use this site, depending on how complicated it is. I have a couple questions that came in through the Q&A, and I see Greg has his hand up. Greg, do you want to ask your question yourself?
Sure. Thanks for taking my question. It's actually a two-parter. I think this might be up Rick's alley. So I came across some very recent scholarly research from the University of Chicago that found that by using climate model simulations, mid to late 21st century Arctic sea ice loss, it weakens the summertime weather system, which the research is saying will mean calmer summers by the end of the century. Can you expand on that? That's part one. And then if you could, part two is, what are the models showing for this coming summer's conditions in winter or coming summer conditions in Western Alaska? Thanks.
Sure. I have actually not seen the paper you're referring to, so I can only comment in general. But I would say, so as we lose summer sea ice, that will absolutely weaken the temperature variation between the very highest latitudes and farther south. Whether that will mean, say, sunnier weather in Western Alaska in the summer because the ice north of 80 north is gone, that is a different question. At the same time, losing that ice, of course, ocean temperatures are going to continue to rise. And as waters warm, Of course, the air, they can evaporate more water from the ocean surface into the air. So depending how things work out, there's going to be more water available to make clouds. So I would say it's a pretty complex issue, especially talking about away from the very high latitudes where that sea ice loss is going to occur. But again, I have not seen that paper. The part B of your question, so the seasonal climate models for this summer, all of Alaska in NOAA's Climate Prediction Center's outlooks that were just released a week ago today, for the summer for all of Alaska is favored to favor the 3-month average being significantly above normal. Now, nowhere in Alaska is it likely to be significantly above normal. Remember, climate forecasts are completely different than the weather forecasts on your phone. You're not getting one value, you're getting a categorical forecast. By tradition, we do 3. So near normal, significantly above, and significantly below normal. For all of Alaska, the significantly above normal temperature category is favored for the 3 months of summer, but it's not above 50%. So it's more likely to be near or significantly below, even though significantly above normal is the single most likely category of the 3, assuming the forecasts are what we call unbiased. So that is undoubtedly as clear as mud, and that is one of the issues that we face with climate outlooks. The future is uncertain, and we like to provide as much information as possible, but it is fundamentally different than the forecast tomorrow that you get on your phone of a temperature of, say, 60 degrees at 2 p.m. We don't do that kind of deterministic forecast in climate world. I don't know if Brian you want to throw anything else in there?
No, I don't have anything to ask or add. That was great.
Yeah, thank you. Wouldn't it be amazing if climate could get dialed into that degree, where it would be? So we have another question that came in through the Q&A. Desiree asks, how can we accurately interpret recent measurements in comparison to historic data when she says it's her understanding the technology has improved in recent years, which it has? Great question.
Well, maybe I'll take the first crack at that. And I would say, I mean, the laws of thermodynamics don't change over time, right? So, we have better instrumentation now, more dense networks of observations, a whole suite of tools, satellite imagery. But that's not to say that many of the observations we took 30, 50, 100 years ago aren't incredibly important and aren't incredibly valuable and accurate. We have, I would say the error bars on temperature measurements that we take today are probably less than they were 100 years ago. But with the central limit theorem, you take enough observations and you're gonna get an accurate snapshot of the state of the climate. So I don't think that just having more modern instrumentation necessarily means that that we have more confidence that this is what the climate is like right now. I think it just means that we have more ability to produce kind of granular analysis and to have a better sense of how we can incorporate that into more modern climate models. If I understood the question, basically.
Yeah, and I would just add, a lot of the change in technology means that we have a more complete picture. So, like that climate analysis model that I showed one version of, we have reasonable estimates of climate variables in places where there are no observations, places where there have never been observations. With sea ice, since late 1978, we have daily estimates of the extent of sea ice. It's not like that prior to October 1978, no one knew or cared about sea ice. There was satellite assisted analysis, but not at the daily scale. We didn't have that. So the increasing technology is basically helping us to resolve things in finer scale, both in space and in time. But as you saw in that March precipitation graphic I showed, the need for quality control and the existence of patently incorrect observations is just as frequent now as it was 50 years ago. So that, in that sense, that hasn't changed. That's part of what this job entails. Is there's a lot of information. Some of it is not good. Some of it might be good, and some of it is definitely good. And that's part of what Brian and I get paid for, is being able to sort through that in a informed
Well,
manner.
and I think really a dramatic example of that was the tremendous snow that fell in Anchorage the first half of December. If you melted all that snow at the Anchorage International Airport, where they have a weighing precipitation gauge called an all-peg, it was about 4.7 inches of water. So if you melted that snow that fell over 12 days or however many days, about 4.7 inches. About the same amount of snow fell at Merrill Field, and their heated tipping bucket, so it has a heating element and it's in theory melting the snows, it recorded 0.03 inches of precipitation. Obviously that's not correct. And without kind of local expertise, and again, that doesn't take much expertise, that takes kindergarten level expertise, but as an absurd example, that would make it into the climate record. And there's a problem when people aren't kind of inspecting it, that NCEI often shows our climate division as being much drier than it is in the cool season, because places like Palmer and Merrill Field and Kenai and Soldotna vastly underreport their precipitation because of the equipment that they have. And so it is a constant struggle, as Rick indicated, to even in 2023 to make sure that we have good data that's being incorporated into the climate record.
If other people have questions, please drop them into the Q&A or raise your hand. Brian, I wanted to back up to something that you said about in talking about average temperatures. You said Anchorage was 34, now 38. When
approximately, yeah.
And over what length of time has that transition happened?
That would be over about 70
lot.
years. So that would be from the early 1950s at Anchorage International Airport. There is a common misperception in Anchorage that prior to the international airport, it was at Merrill Field for decades and decades. In reality, it was at Merrill Field for 9 years. And before that, it was at several locations downtown, different locations of federal buildings. I think a post office, don't quote me on that, starting in February 1916. So for almost 30 years, it was downtown. For 9 years, it was at Merrill Field. And then for the last 72, it's been at Anchorage International Airport. And it's important, especially in some places like Anchorage, even more important in places like Juneau, that we as best we can, we use the same location when we're computing trends. Because as most people in Anchorage know, on cold days, it's colder at Merrill Field than it is at Anchorage International Airport. On warm days in the summer, it's warmer at Merrill Field. Now, over the course of the whole year, the two are very, very close in terms of their average annual temperature. That's not the case in Juneau, and especially for precipitation in Juneau. So it is important that we keep track of these things, station moves, urbanizations.
All right, thank you. Rick, a question that I put to you after Murbach slammed the coast and we had you guys on to talk about what had happened. You said we should expect more extreme weather to become more common here. How should people be thinking about and preparing for that and thinking about it? And I'm thinking of, how should reporters be thinking about how they can best cover and present informational stories that could help people understand this?
So it's a great question. Certainly as a very, I would say, a minimal step in preparedness would be what's happened where you want to be prepared for, in the known record. We haven't had a big flood here since 1955. Well, there was a big flood in 1955. It could happen again. But the reality is that many events that we are seeing, and more in the future, exceed anything that we know about, in some cases by a lot. And so merely preparing for the worst that's happened that we know of is not going to be sufficient, but that's at least a minimum place to start. As far as reporting on these extreme events, I think it's really important, as Brian showed in his El Nino slide there. We have a lot. I mean, there's basically an infinite number of moving parts in the atmosphere of the ocean, the climate, Earth system. Some things are more important than others. El Nino, La Nina in the winter season, in the cold season especially, is quite important in what happens in the northern hemisphere, and in particular in the places, the Pacific Ocean and lands bordering the Pacific, like Alaska. But it's still only one piece of the puzzle. So we've got that. We have this long-term trend that many of you have probably heard me refer to as, that's kind of the background that our weather is occurring on. And every year it gets just a little bit redder. Year to year, the change is almost imperceptible, but 1950 to 2023, it's obvious. We have things going on in the stratosphere that over time affect what's going on at the ground. So there's all these moving pieces. And I think for reporting purposes, I think you could help people to understand these by not asking, was this caused by climate change? Was this caused by El Nino? Those are ultimately not well-formed questions, because there's always other things involved. And so emphasizing the right part is important. Using Merbach as an example, as Brian showed, Merbach formed in a part of the subtropical Pacific where typhoons historically very rarely formed because the water was too cold. But last year had near record high sea surface temperatures in that area, warm enough to support tropical cyclone formation. But a lot of other pieces had to come together. You had to have the large scale steering flow move that storm towards the Bering Sea. Merbach could have formed there, but if the large scale steering flow would have been from the northwest, it'd have moved to the southeast and no one would ever remember Merbach. There's a jet stream feature that drove into Merbach from the southwest as it approached the Bering Sea. That helped it deepen. It was unrelated to Merbach. If that wouldn't have been there, wouldn't have been nearly as strong a storm. There's all these pieces that have to come together. And so helping readers understand how these different factors come into play. And, okay, you maybe don't want to get into all that technical detail, but climate change, for instance, or warming oceans, that was close to a necessary ingredient for Merbach, but it wasn't enough to make the terrible storm that we had in Alaska from it. We had all these other pieces come together.
If I could add to that, more kind of big picture, and that is, from a press and reporting point of view, one of the most common questions that I receive, and also that I just hear casually, is, was this caused by climate change? And as Rick noted, that's really not the way that should be asked. because there are so many moving parts to it. But I think a better way to ask the question would be, what was the contribution of a warming climate? And so, as Rick noted, the Murbach situation had, it had 10 different pieces to this puzzle. But, some of those pieces didn't really even exist, decades ago, or were very obscure. And so, asking what the contribution is, asking what the likelihood is. And those are nuanced questions, and those often produce unsatisfying results. If you were to say, well, what was the contribution? I would say, well, we think, over the next 50 years, given this scenario, we think there's a 17% greater probability of this type of event occurring. Well, that doesn't make a very good headline. And, I understand that. But that's the reality of the way that we frame it. Otherwise, if we were just to say, well, La Niñas are dry in California, La Niña winters, and El Niño winters are wet. Well, California had a near record wet winter last year in what is normally a dryish regime. So if we say, well, before then, well, yeah, La Niña, it's going to be wet, and then it's going to be dry, and then it's not, then all of a sudden, well, I mean, from a professional point of view, it looks like we don't know what we're doing. And then, people then also have different expectations for what will and won't happen. And I think another good example as well, sometimes in the summer, there's a 20% chance of rain. And if you get rained on, that looks like a terrible forecast. But it may be a great forecast. Maybe only 20% of the people got rained on. So it's hard to explain things in a probabilistic sense, but we really live in a world with shades of gray.
So if no one else has any other questions, we'll wrap up here in just about a minute. But my last question to you before we do wrap up, if someone else wants to jump in here, you're welcome to do so. Otherwise, I would just ask, I read recently a climate scientist was talking about climate doomers, how this particular scientist said, I spend more time now arguing with people who say it's too late, we can't do anything, it's over, than this person did arguing with climate deniers. So this seems like it has the potential to be a real problem, because if people give up, if they just think, well, there's nothing to be done, it's, I'm just going to be depressed, then they're not talking to people who can affect policy and make things happen. So any thoughts about that? Do you hear that? Do you hear more of that now than maybe in the past? People just saying it's too late to do it.
I'll jump in first. Well, I think there's really two ways to look at it. I think, there's always, there's kind of a running joke where there are certain people that say it's not happening, it's not us, it's not as bad as you say it is, it's too late, right? And so you end up with that being the continuum. But those people really aren't acting in good faith anyway. There is a lot of discussion I've heard about, climate doomerism, on the activist side, that we've got to do everything we can now. Everything else is unimportant. All of our energy should be focused on this, or we're all going to die. Our kids are going to die. There's not going to be a planet left to live on. And I think to some degree that's a little bit overstated. There's it used to be, why aren't you taking this seriously enough? And then I think a snapback reaction to that is, oh, you're taking this too seriously, or your perspective isn't, you need a broader perspective. But I do hear a lot of people talking about doomerism and how that is counterproductive, that you need to give people optimism, you need to give people opportunities to make changes, that you need to you need to be encouraging that, hey, we can do this, we just need to work together, instead of what's wrong with you, or we can't do this, or I'm just going to go live off the grid somewhere.
Anything you want to add?
I'll just finish up with it's a different. Yes, it's bad, and it's gonna get worse, but that is no reason not to do everything we can now. If you buy paper straws, all will not be fixed. But even though it's bad, that does no reason not to take action now and in the future. That's the only choice we have.
And Lori, you probably don't remember this, but about 5 years ago, I was on with you on Talk of Alaska, and someone called in, and part of they kind of critiqued, well, why are you seem to be laughing, having a good time. This is really serious. You need to be basically taking this more serious. And so this is it's not a new phenomenon. People have different either coping mechanisms or ways that they go about trying to make changes. So but I do always try to give people encouragement, hope, we can do this, but not in kind of a magical fairy dust way, just by saying, hey, everything's going to be just fine, just hang in there, because that's kind of magical thinking, and we have solutions to deal with stuff, but they don't involve magic.
Darn it. I was hoping for some magic. All right. Thank you so much, Brian Brettschneider and Rick Thoman, for sharing your vast wealth of knowledge and important information with us. Thanks to all of you for taking your lunchtime to join us today. And I also want to say thanks to the Alaska Press Club for hosting this with support from the Alaska Center for Excellence in Journalism. That's the fund at the Alaska Community Foundation. And also many, many thanks to the Atwood Foundation for their contributions to that fund and for their continuing support of Press Club and other events. So thanks, everyone. Have a good rest of your week. Bye.